Okay, in this video, I will show you how to do scattering matrix simulation for coplanar waveguide for transmission line with Launchpad by interfacing the Python Jupyter Notebook or Qiskit method to HFSS. So now we already have the setup. We won't go into the details, but now we would want to target a resonator frequency that is 4 gigahertz. So we will run everything. So when we run it, it will bring up the Qiskit method, and then it will start doing the rendering. It will take some time, so let's wait. And at the same time, after this is done, it will start drawing the structure on HFSS. You see, this is the transmission line, right? And then with the resonator. So this resonator, I click on pen, and then I can drag it. I use my middle button to zoom in, and you can see this transmission, this resonator is shorter at one end. I just press escape, so my mouse can go to here and click on this, right? So it's shorter to the ground plane. And then I use pen and then come to here. And now you see that it is, we make it a little bit too long, but here it is open-ended. So this is a lambda over 4 or quarter wavelength resonator, right? And here is the Launchpad. Okay, so the Jupyter Notebook has brought us to here, and as you can see, what we did is we just call HFSS render right after we create all this structure, and then send it to HFSS. Now we did not mention what's the port. We need to assign the port, but up to now I still don't know how to assign the port for Launchpad from HFSS from the Jupyter Notebook. So now we did not assign any port. In order to simulate the scattering parameter, we need to assign the port. So we need to do it manually here. But to save the time, I'm going to record what has been done. And then later, when I try different length or different resonance frequency, I can reuse it. So I go to the, where's that? Automation. I said record script, right? And then I just call this, let's say call it port, and save as port.python. Okay, so it's going to record what I'm doing. I use the middle button to zoom in. Again, I go back to draw and then pen, right? So that I can pen it with my left mouse button, and I use the middle button to go in. So now I'm going to insert a rectangle, right? So I will click on pen so I can move around, and then I need to press escape so that I can click on this corner. So this is the port that I'm going to assign to it. I use middle button to zoom in so that I want to go all the way to here. Now zoom out and then pen to move it. Now you see that this is the maybe niobium, the conducting region. This is the ground plane. All right, so the port is connecting this middle line, which is the signal, to the ground plane. Okay, so I right click and I say assign excitation port lump port, right? Just okay. It is 50 ohm, and I need to add an integration line. I click on this new line, and then when I come to here, I will just click at this edge, and then I want to go to that edge, so I'm going to use the middle button to zoom in and then click on it, right? And then just say next. Okay, right? So now I have assigned a port. Let me fit all, right? If I try to go to here or here, I look at the excitation, I highlight this. This is port 1, right? You see it has assigned port 1. Now I want to assign port 2 to it. So I come to here, zoom in, like what I did earlier, pan it, right? Move around, and then I add this rectangle, not the circle, click it wrong, escape, right? Rectangle, click here, right? And then drag it. Now zoom in. so that I want to align here. So I need to click on pen so I can move to here, escape so I can continue to draw, and then click on here. Then I finish this, right? And then right click and then say assign excitation port, num port. Again, this is port 2, right? I need to draw a 9 and zoom out again, pan it, right? I want to put more at the middle, and then I'm going to do escape so I can continue draw, click on it and drag to here and then click on it, right? Then say links and then finish. Then I'm done with 2 ports, right? So now I'm going to stop the recording so that I can reuse it later. So stop, right? So this is done. And then I come back to draw and fit all. So I'm done. I can do the simulation. So I go to analysis, right click the setup, and then say add sweep frequency, right? So I want to sweep it from, let's say 1 to 20 gigahertz, right? And interpolation 4001, right? So this might not be accurate enough. We need to think about all the spacing, the mesh, but now we're just trying to demonstrate the method. With this, then I go to tools, and then I say, no, HFSS, then analyze all. It will force me to save it, and it is running here. And yeah, let's just wait for a few seconds. Right, as you can see, it's just running. So while it is running, let's look at the design, right? So here I have some number here. We are targeting 4.1. This is the length of the resonator we put is 4.1 millimeter, right? We multiply it by the average of the dielectric constant, which is 1 on top is the air, and then 11, I put this wrong, should be 11.9. 11.9 is the silicon substrate dielectric constant. So we take the average, take the square root. So the wavelength of the length of 4.1 multiplied by this dielectric constant would be the real wavelength when it is in vacuum, right? And since this, and then I just use the speed of the light divided by this length. But of course, this is quarter wavelength, so I divide it by 4. And with this, right, then I will get the frequency should be about 7.2 gigahertz, right? But however, what did we put here? I need to make sure. Let me go back to this notebook, right? So what is the length actually? The length actually is, in this design is 8.2. So I should put 8.2 instead of 4.1. So we expect a resonant frequency of 3.6 gigahertz. Okay, so I hope this is clear. What I'm trying to do, let me say again, what I'm trying to do is just that we have this resonator which is 8.2 millimeter, right? And it's quarter wavelength because one end is shorter and other end is open. So the resonance mode will be for the wavelength that is 4 times of its length, right? So but I try to correct with the dielectric constant. So that mode will correspond to 3.6 gigahertz, right? Because if you find the wavelength of 3.6 gigahertz in the vacuum, and then you divide it by the refractive index, right? And then divide it by 4, then you will get 8.2. Okay, so we have this now. So let's look at the result. You right click result, create model solution, data report, plot rectangular plot. We're looking at S parameter. Let me look at both S11 and S21, right? In dB. Okay, so very nice. So what do we see? Now, if you look at S11, S21, this is the transmission, right? We already designed it so that this has a characteristic impedance for this transmission line to have 50 ohm, right? So they should have all like 0 dB of transmission, right? Which is 100%. It's not exactly 0 dB. We did not design it perfectly, right? But it's pretty close to 0 dB. Okay. Another thing is that we see it has a dip. Why it has a dip? This is because when it reached the resonance frequency of this hanger, of this resonator, right? This is shorter. Then it interrupt it. It just make the effective impedance no longer 50 ohm, so they cannot transmit through, right? So based on this, what is the frequency, right? So we can right click, marker, add marker, look at here. So this is about 2.8 gigahertz. Okay, so it's not exactly the same as what I got, 3.6 gigahertz, for a real reason. First of all, when I say it is 8.2 millimeter for the design that we have here, right? We say 8.2 millimeter, but it is more than that because we actually, that number is only for this region. We have something longer, so it is smaller. Okay. Okay, but that's okay. How can we prove that this is correct? Right? What I can do is I go back to my original notebook. Instead of asking for about 4.4 gigahertz, right? Let's make it double, right? So our target is now double. Okay, so I want to rerun it, right? To rerun it, I want to close this guy first, right? So just remember, now what we have is this graph, right? Make it fit everything. I have some pretty low frequency at 2.8 gigahertz, right? So I'm going to close it. I'm not going to save it. Okay, so I'm going to run it again. Run all. Okay. So it will again bring up the Qiskit metal, right? This one was from the previous run, and this is the one that is running, but because of the programming, it does not show up until it called the HFSS, so we can ignore it. So let's look at HFSS. Right, so again, constructing the transmission line, constructing the hanger, the meander, the resonator, right? And then the launch pad and the bridge, and then the simulation domain. Now, again, we need to add the port, right? But since everything else is the same, then I'm going to just run the script that we just had. So I'm going to call it port. Hopefully that will work. Let's take a look to see if that works. Doesn't look like it is working, unfortunately. Okay, so looks like that script only allow me to run on the same project. I might need to do some modification. So let me see what I can do. So let me just copy this. Right. Then I can see if I can. Okay, so I have opened that file, right? And you see that the reason is because it tried to, I believe it's because it tried to look for project 21, but this time it's project 22, right? So I change it and I save it, and then I will see if I can run it again. Okay. So I have copied the file to another location. Now I'm going to open the modified port file. Okay, it does, right? It does work. Very good, right? 1, 2, right? So maybe I should also copy the setup at that time. But anyway, it's easy to add the setup. So now I'm going to add 1 gigahertz to 20 gigahertz, right? Let's say 4,000 point. Say OK, and then HFSS analyze all, and then okay, doesn't matter. Just save somewhere. So it's running again. So when it's running, right? So this time, we have put in how long? 4.1 should be 4.1. The length should be about 4.1. So I just copy it to here, right? If I put 4.1, then I will get a resonance frequency of about 7.2, right? So yeah, we do have 4.1 here, right? Oh, I thought we already done. Okay, so maybe it was not updated. Okay, I'm sorry. Apparently, right, the length was not updated, so I will get the same result, which is fine. Okay, let me quickly change it. Okay, do it one more time. Yeah, apparently I need to modify from here. I did the wrong thing, so let me modify from here. Okay, so ignore, we have a lot of qubits, so please ignore it. So I will modify from here. So I will just stop, abort. Okay, close it. I cannot close it because I need to disconnect the communication. Close. Then come back to close it. Not going to save it. And then run one more time. Okay. And now I'm going to change this one to 23. Right. Going to save it. 23. And then I just wait for it to come out. Okay, so now it's reconstructing. Hopefully this time is correct. Indeed, I see it is shorter, right? We can also confirm from this script, print out, oh, but it is still running. We need to wait. But yeah, but it is shorter for sure. So now I'm going to run the automation again, right? Run script. Again, do this pot. Okay, unfortunately, it's still called 22. Okay, so that's why it doesn't work. So I need to call it 22. Project 22, right? Somehow I did not save last time. So run one more time. Script pot. Okay, then let's do the analysis. This is the setup. By the way, you need to make sure the setup frequency less than 1 gigahertz, okay? The minimum one. Okay, do not make it too large. And then right click and then add frequencies with, let's start with 1, 20, 4,000 point HFSS validate, save it again. Okay, 22. Now you can see this is shorter than what we had before, right? Okay, so it's done. Let's right-click the result, generate the mode, the plot, right? Again, we want to S11, S21 in dB, new report. Okay, now you see that I have a peak here now, right? Instead of about 3, now if you zoom in, middle button to drag it, right click at a marker just to see where it is. It's about 7 gigahertz, right? Again, not exactly the same because one is our mesh might not be good enough. Another is because we have the length is not exactly what we put there. We have some calculation issue that we did not take those ending into account, right? So this is only the main length in this part. Okay, so in summary, to do scattering matrix, you need to make sure that for Launchpad, you need to make sure that you have the lump port set up correctly.